Hello and welcome back. So continuing on with our discussion of ANTLR in this video, we're going to be looking at lexers and parsers, but more specifically, Nelson?
Yeah, we're going to be taking a look at how the generated lexers and parsers that ANTLR creates for us, how they actually go about and turn a string of input into a parse tree. So we're going to be taking a look at a basic ANTLR grammar file, and it's not necessary that we go over every bit of the grammar file, but hopefully by the end of this video you'll see how each bit of the grammar file actually relates to the input stream.
Okay, sounds good.
Yeah, so we have three things here. We have the grammar file, which is right here. We have the input, which is right here, and we have the parse tree that's being generated by going through the input. So this grammar file is very straightforward. The actual syntax, like for example, right here, isn't necessary. You don't necessarily need to understand it, but hopefully by the time that this is over with, you'll have an idea about the process that happens with ANTLR. Then we'll cover the individual syntax that you see here. You might be familiar with some of the syntax already. For example, the pipe symbol is used to create an OR statement, just like in a binary OR operator in a language, as well as the star is borrowed from regular expressions, which means one to many, or zero to many, but we'll get to that. So the first step that the lexer and parser classes, which aren't represented here, I kind of want to, with the idea of this whole exercise is kind of to abstract the idea of the generated C# code from the actual process. So what we're seeing here is how the grammar relates the input to the parse tree, but remember that in production, it's actually going to be the C# lexer and parser that ANTLR generates from the grammar that's going to do all the heavy lifting.
Right.
So the first thing we're going to do is we're going to hit the test text instead of our input. And already what we have here is a parse tree, because basically what ANTLR is going to do is it's going to examine the hierarchy of your rules and find the first bit of physical text that it can match. And if you look down here, the relationship between these rules, and options is a collection of option, and option is an identifier followed by a colon, followed by a number, followed by an optional new line. An identifier is A through Z or capital A through capital Z. So remember, what's represented in teal here are lexer rules. So the lexer is going to parse test as an identifier because it is a collection of zero to many of these characters. And because this is the first thing that's matched, this is the first hierarchy of the rules that get identified. So you'll see we start off in our parse tree with our options rule, followed by our option rule, followed by our test rule, which test is actually a token of identifier. Mm-hmm. So the next thing is the colon. Because ANTLR now knows that we're dealing with the option rule, it's going to say, okay, we found an identifier, that's awesome, but the next thing we want is a colon. So we're going to make sure that the next thing that we receive is a colon, which in this case is true. The next token that is parsed out of this input is indeed the colon token. The colon token is defined as a literal colon character. So now you'll see that in our parse tree we have options followed by option, followed by our identifier token, followed by our colon token. If we click one more time, we're going to see 42. And the reason is because ANTLR knows that we're inside of this option inside of this rule right now. It matched the token or the colon, so it's done with the colon, and it moves on to the next thing that needs to match, which is the number. The number is going to be this token right here, which is represented as any string of text that is the literal 0 through the literal 9, one to many of them. So a number could be 42 because that is 2 of these individual bits of text. So we see that 42 is now matched. So what happens now? Now we actually hit the new line. In this grammar file, we're actually parsing new lines out as tokens, which means we can use them in our lexer rule or parser rules. So now you'll see up here, the next thing after a number, we expect an optional new line. Now, this is important because this is optional because of that question mark, which means that if ANTLR didn't find a new line, it would say, oh, okay, well, we're done with the option rule. Let's jump up back into the rule that invoked option. In this case, it did find a new line. So in this case, that new line gets added as a token in our parse tree. If we continue, the same process is going to happen again. What happened after this new line was the rule ended. The option rule ended. Think of it like the option method ended. So it returned to the caller. The caller is the options rule. Now the options rule is simply zero to many option rules. So in this case, it's going to say, okay, well, let's see if we can go ahead and match another option. So option, can you be matched? And option says, well, my first token is identifier. Is what we're sitting on an identifier? So it asks the lexer, is what we're sitting on an identifier? And the lexer says, well, yeah, because this text matches this rule. So now we have this parse tree, where we have the options followed by two option rules, and then in this case followed by the final identifier token. If we continue, ANTLR again is going to say, well, a colon needs to follow an identifier. Let's make sure that is true. In this case, it is true. The colon follows the identifier. It now knows it can proceed like normal. The next thing is the next thing a number, which again asks the lexer, hey, is what we're sitting on right now a number? And the lexer is going to say yes, because what we're sitting on matches this rule right here. In this case, what we're sitting on is 421.
So I take it at any point. As I take it at any point as we're going through and looking at each of these requirements for the option with the specific parser rule that you have set up right now, if the thing that you're sitting on at the moment happened to be, let's just say, XXXXX, it's just some sort of set of characters as opposed to a number, we would end up generating an error?
Yes. It'll generate an error. It'll throw an error. It'll say, hey, blah, 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 was expected but not found. Then what it's going to do is think about it kind of like a try-catch block. Mm-hmm. It's going to unwind the stack until it finds the easiest way to resume. So, for example, if I had whoa colon XXX, and then I had everything at the stuff colon 435 following it, it would actually jump back into the options rule and say, okay, let's find the next character that'll match an option, in which case it's going to be this identifier, because remember, an option is matched first by an identifier. Mm-hmm. So it does have a recovery mechanism built in, but it'll also throw an error that you can catch in your code and display it to the user. Nice. Okay. So now we're sitting on 421.
241?
241. Wow. I'm not going to say that again. Now we're sitting on the number that is currently in teal.
Right.
And we see that is now represented in our parse tree. If we continue on, our invisible new line character gets picked up, gets parsed properly, gets sent to our parse tree, and we continue on again to this one. So the same thing happens. The identifier followed by the colon followed by the number.
So looking at this, unless I'm wrong here, one of the interesting things that's happening that you have not shown going into the parse tree, I guess because it's going into the hidden channel, is in that parse rule, between identifier and colon and number and new line, the spaces that are getting picked up from your input over there, such as between the colon and 42 on test, that's getting picked up because of the lexer rule and put off into the hidden channel?
Yep. Because we have a lexer rule down here called space, which is defined as zero to many space characters, then we have this special action right here. So if you can't see that, that's a curly brace followed by a $ channel equals hidden semicolon. What this is going to do is this is going to instruct the lexer that this particular lexer rule should be hidden from the parser, and the parser should never have to worry about it. So that's how we make white space insensitive languages, by adding a rule such as this to our grammar file.
So in this case, if on your input you would have had test and then a space and a colon, would that have generated trouble?
No, it would have parsed just the exact same way.
Okay, cool.
So finally at the end, this is what we get. This is the result. The input has been completely matched by ANTLR, and we're now at the end. Basically what happens here is the option thing finally runs out. Option says, okay, are we at the end of the stream? We are. Let's go ahead and exit because there's nothing else for us to do.
Nice. Okay.
So,
that's pretty straightforward. Okay, so that's going to wrap this video up, and in the next one, we'll surprise you guys. All right. So that's going to conclude this video, and we'll see you guys in the next. Thanks a lot.